Assalamu alaikum everyone. Today I will be discussing about the rest of the part in SimaPro analysis. I have already uploaded 2 videos on life cycle modeling principle or the basic principle of life cycle modeling, and in the second one I discussed about the SimaPro analysis. So those of you have not seen those videos, I would highly recommend you to go through those videos. I will put those links in my description box. Please feel free to go through those videos, and those videos are here. One is this one, fundamentals of life cycle analysis with some case studies, and the second one is tutorial on life cycle analysis using SimaPro software. Okay, the problems we are discussing in the first tutorial of the SimaPro software was problems. We have coffee machines, so we want to design 2 coffee machines. One is with plastic and another one with aluminum. So the plastic one will be consisting with hot plate, and the second one, which is made of aluminum, will be with thermos jug. Okay, so and then we will compare this one with aluminum one and see which one has less or higher environmental burden. So we have already discussed this one, the plastic hot plate. Today I will be discussing about this one little bit and then comparing these two, and some other steps remain in this part of the tutorials. Let's start. If you watch those videos, and especially the second one, which is on SimaPro analysis, you will be seeing that I have discussed this coffee machine one, assembly part of that coffee machine, especially this plastic one. So today I will discuss with aluminum one, and then we'll go through these other steps. Okay, so let's start this one. Just double click here. So once you double click, you will be getting this windows, and there are some toolbars here. From those toolbars, just click this one, analyze. Okay, once you click this analyze, you will get this window, and the method is already selected, the receive endpoint method. So since this is already built in, I'm just following through the step-by-step processes, so we don't need to select the method. Other than that, if you are doing a fresh analysis, in case in the case of your cases, so that cases you need to select your method. Just you need to click it here. For example, I showed it in the previous tutorial, but to recap, just click here. Then these are the methods. So this method has been selected here, so I'm not duplicating it again, just cancelling it. And in case of other databases, you can choose other methods as well. Okay, so just cancel this one. Now I will do the calculation here. At the bottom you can see the calculate and close button. Just click on the calculate. It's calculating. Okay, so this is the results. I have already discussed these results. This is impact assessment results. So I'm not going through all these details, but for those of you who are new here, so I will discuss a little bit for them. So first one is the network. So once you click network, you will get this pop-up window, which is not all product of this network are currently visible. 12 out of 16 is visible here. So just click OK, and this is because of your cutoff. Okay, node cutoff is something which you can play with, so that you can get more number of nodes. So this 2.59 means those who has the environmental burden of less than 2.59%, those nodes will not be appeared here. So that means up to, I think 2.59 is the least amount of environmental burden from the process and the product are given here or the shown here. So let's try with this one. For example, I want to see up to 2%. Okay, so if I click here 2%, so there is no options for 2%. Like that means the 2.59% is the least amount of environmental burden we have in this system. It has moved little bit because of the Shankey diagram. Okay, so you can like move. I will discuss this buttons a little bit more. So let's try with 3%. Then you can see this 2.59 will disappear. Let's put 3%. See, so this 3% is the least amount of environmental burden from the process are appeared here. So hope you have understood. So in this buttons, from this navigator you can choose to make it bigger or zoom in and zoom out using this button. I will use this one like 1.4 1.5%. okay, so that I can see all nodes together. All right, so now this is the single score. So I have already discussed a little bit about what the single score means. A single score is the weighted percentage of your environmental burden from the processes. So if we click this one, this is already ticked, which is a percentage in the percentage form. This is 100% of the assembly model. Okay, so to note, this is the assembly model's life cycle analysis. I will do the whole life cycle analysis in the second stage. So assembly model 100%. okay, for the aluminum one, and housing comprises 71% of the environmental load. You can see here. Small parts 10%, thermos jack 8%, and cable or something, mains cables, the electric cables 9%, 9.73%. So this is altogether 100%, and further breakdown is given here. So out of those 71%, aluminum contributes 66% of our environmental burden, and tubes 4.7%, and so on. So same things are described here. So I'm not discussing more here. So you just need to explore by yourself. Okay, so this was the Shankey diagram. So you can just play around with this Shankey diagram to make it to see which part has the more environmental burden. Like the thicker lines has more environmental burden. As you can see, 71%. This line has the is the more thicker than the other trees. So you can see this. If you don't like this one, you can present as a without putting any thicker line or thin lines. Okay, so this one is the color of your processes. So this blue and the legends are here. So this blue represents the assembly, the environmental burden from the assemblies. So this blue, light blue. However, this materials is represented here with the green, light green. You can see the legend here, materials. So materials is represented by the light green, aluminum, for example, steel, polypropylene, copper, etc., etc. The energy is the heat energy from natural gas is represented by this color. I don't know the color name. So you can see the legend here. This is the legend. Okay. And show process image. Yeah, you can show the process image. Like this is the housing picture of the housing pro, small parts, thermojag, and etc., etc. And depending on your choice, you can play with. And this is the layout of your Shankey diagram or the tree. You can move around using this one, and the show top process only. This one is the show top process only. The top process, once you click top process, it doesn't make any changes because we have already set the criteria for the 3%. So up until 3% it will appear. So you can change it to 2.5%, for example, 2.5%. Yeah, as I've shown before. So the 2.5 one, another one is appeared here. So now this is almost the same things. If we go to the impact assessment, okay, just taking a bit of time. Assessment, okay. So impact assessment has a different analysis. One is damage assessment, normalization, weighting, and single score. So you can play around. I have discussed in the second tutorial what those means, so I'm not going in detail, like what contributes housing, what contributes small parts, what contributes thermos and main bolts. These are given here, and relative contribution of on human health, ecosystem, and resources are given here. And you can see the weighting, and for a detailed description of those things you are requested to go through the introduction of a SimaPro tutorial, which is the theory of the SimaPro, where you can get all those definitions. And this is the single score impact assessment. Okay, so I'm not going through all these details here, like inventory, process contribution. These are already discussed in my previous tutorials. Okay, this is all about the assembly model of the aluminum one. Okay, so let's close this one. So close this one. So now before comparing, I'll do the comparison at the end, and we will be able to see interesting results. So before that I will, so this assembly is the first part of our life cycle analysis. But in our life cycle analysis, in this model, we have already included other steps as well, so like disposal scenario and so on. So we will go a bit further here. If we click life cycle here, okay, click life cycle, and you can see the coffee machine demo is here. Just click here. Okay, so from here you can see life cycle model Sima plastic, life cycle pro, no touch back. So if you go to this one, you can see the entire life cycle of the system. So this one, again I am repeating, this one, the assembly one is the for the assembly only, and life cycle one includes all the steps including disposal. Okay, so the double click here, and the same thing, analyze and calculate. Okay, so from here you can see the network diagram. Same thing is like 12 out of 48 is represented here. So this is very tiny amount, like 0.84%. So we can ignore those. So 12 node is enough, I think. Okay, so from that, let's make it a little bit bigger. Okay, so as you can see here, so sometimes this cannot be 100%. So in that cases you need to click here. Make sure you click here so that you can get the results in 100%. Okay, so now in the single score, this is the percentage. As you can see here, assembly, electricity, and use of coffee filter. This is the additional things added here in this model. So we did not see this one in the assembly model, like use of coffee filter. This is the disposable one, like in the coffee. So here, as you can see, 10% of the burden is from the coffee filter. So this filter, if you dispose it, municipal solid incineration, paper, and filtration product, these are the processes we had to do for the disposal of the coffee filter. And there is a trade-off by disposing this coffee filter in terms of environmental impact or burden. So we will check it later in the incoming processes. So hope you have understood this one. So yeah, you can check all those three, like all those things here, tree, and impact assessment already discussed, and all those things you can discuss. You can check for full life cycle as well. I'm just closing this one again. Okay, close. Okay, life cycle, no take back. This means we're just disposing it. We're not taking it back to our system. So you can check, you can read through this one to check the functional unit of our system. Okay, just click a little bit here, analyze, calculate, calculate. Okay, so now you can see in the network diagram same things. Okay, node, as you can see in this system, likewise what we have seen in the previous Shankey diagram, that there had a system of disposal. The disposal unit, we don't have that disposal unit here. Disposal system like recycling, incineration, and so on, those steps are absent here. So in terms of if we want to analyze like without taking back anything from the disposal scenario, so you can use this one. Just close this one, close. All right, close, close. Okay. Individually you can check the disposal scenario here. Okay, coffee machine demo. Okay, for Model Pro, dispose of the aluminum parts. So you can see the individual sections. Double click, I'll just show this one only. For example, aluminum parts, what we can get out of it. Analyze and calculate. All right, so this is once you pose aluminum parts, you can get something positive out of it, which is represented here in the impact assessment. Let's go start with the network here. 4 out of 5 is represented here. Okay, so this one represents the recycling only and recycling. So these are the process, additional process in the disposal unit, and 3 is almost same thing, but here you can see the percentage. Okay, so one thing to understand from here is this represents the positive environmental impact, which is represented in the green bar or the green lines. So recycling only, avoided recycling only, this one is 1.5 kilogram, 1.5 kilogram recycling aluminum. So this is the positive trade-off or the positive impact by the recycling, and this impact we will see in the impact assessment. If we click here, and one thing to understand here, that this is transport lorry, so this is negative one, because for the recycling you need to transport your waste, so that's the reason you need to spend a bit of energy and resources. That's the reason it's a negative here, this one. Vice versa, like if you see the percentage, you will get this one positive. If you see without percentage, this one you will get negative. So that means this is opposite of this one, and you need to spend a bit of energy and resources from electricity as well. So electricity and transport, these are the environmental load in terms of negative environmental load. This is the positive environmental load. Because of the recycling, you are getting out of it something out of it positive. If you go to impact assessment, you can see, so this is positive, and human health, ecosystem and resources. Some are positive in terms of electricity, low voltage production. Okay, so electricity, if something is positive, that means this is the environmental burden. So you are consuming electricity, there is environmental burden in terms of human health, ecosystem and resources. And same thing is this one as well, transport. In terms of transport, you are spending or you are consuming your energy and resources. That's the reason it's a positive in negative environmental burden, which is above 0. And this negative means the positive environmental burden. That means we are gaining something in terms of positive environmental burden. This can be a bit of confusing, but I will try to explain. If you have any confusion, just write down in the comment box. So the recycling gives you the positive environmental burden, like you are saving your environment. That's the reason it's negative. Okay, negative points. So resources, ecosystem, and human health. All right. So this is what all about this disposal. Let's close this one. Close. All right. So same thing, you can check all this disassembly and reuse. For example, if I see this one, and in order to avoid making this video bigger, I will not go through all these steps, just checking this one, assembly, what impact we have on in terms of assembly. Just click here, Model Pro, double click. All right, so analyze here, and calculate. Same thing, like in terms of impact assessment. So disassembly. So for the disassembly, electricity consumption, you are consuming electricity and you need to transport as well, negative environmental burden. Okay, you can dispose aluminum parts after disassembly. So this is the positive environmental burden. And incineration, this is above 0. Once you incinerate means combustion or like burning it out. Okay, so those who are not familiar with these terms, so burning of the waste, that will give you some environmental impact, like that will give you the emissions like CO2, NOx, etc., etc. So that will affect our environment. That's why it's positive negative environmental burden due to the incinerations. You can experience all those things in your discussion or the discussion or interpretations, and you can play around with all these things, like what this positive means, what this negative means. I have already discussed. Okay, damage assessment, positive and negative, you can understand from here, single score. Okay, in order to keep the video concise, I will not go through reuse phases, like it will be the similar things of disassembly. So just go through this and play around. Okay, and the final thing I will discuss is the comparing the products. What we have, as we discussed, we have two products. One is named as Model Sima, other is Model Pro. One is made of plastic and the component is hot plate. Other is aluminum thermos jack. So we will compare which one has more environmental burden in terms of different scenarios. Okay, let's do assembly. Okay, and click coffee machine, then you will get these two, Model Pro and Model Sima. One is made of plastic and another is aluminum. So just click one here and the control other one. Click one here and then press control and click other one here. Then control this one and then go here. You can see this network, tree, analyze and compare. Just click here. Once you click there in compare, you will get this window. We have seen this many times. So calculate, click calculate. All right, so we have got the results. This one is single score impact assessment. In the single score impact assessment, here you can see the environmental burden of those two processes. One is aluminum and other is plastic. Here we can see on human health, ecosystem and resources, in all three categories, this Model Pro made of aluminum has more environmental burden. Again, I repeat, in terms of human health, ecosystem and resources, this Model Pro made of aluminum has more environmental burden compared to Model Sima made of plastic and hot plate. All right. Probably if you do the comparison, it's altogether 0.9 and it's altogether 1.7, almost double environmental burden because of the use of resources and materials. Okay. And go to inventory to see the detailed analysis or the detailed comparison, like this amount, this substance has been used this amount, or in the air. Okay, impact in the air, this 9.13, and this plastic has the impact of 2.9 nanogram, I believe, Ng on air. Okay, and there are hundreds of substances here, so you can check all details in terms of nanogram, microgram, okay, milligram, and so on, like aluminum waste. In terms of aluminum waste, of course you can understand that from aluminum this has like 49.2 gram of waste. Okay, and this plastic does not have. It can be vice versa from plastic as well. If you see the plastic, if I go to plastic, polypropylene something, then you can see this one is aluminum is crossed, like aluminum does not have any impact or something like that. Okay, you can go through all these things. I'm not making it bigger, so you can understand what I'm trying to say. So the process contribution, you can see from all this process I have already discussed in my first tutorial in the SimaPro. So okay, and impact assessment, you can do this damage assessment, you can do the comparison with like human health. It has more impact, this aluminum one, compared to the plastic one. In terms of ecosystem, this one has more impact. Okay, and if you click, and you can see the setup here, like settings here, like this is the method, this is the normalization techniques, and you can go through all these things. You can play around, and resources as well. So in all three categories, aluminum has more impact compared to the plastic one. You can do the comparison, normalization, you can see the weighting, you can do the single score, and you can play around with the graphs and so on. So once you have done all those things, this is the time to analyze the results in Microsoft Word or something like that. Now if you want to extract the results, you can see this one copy button. You can just click here, but unfortunately I will not be able to copy or extract the result because this is a demo version. If you want to extract the results, you need to have your licensed version. So just copy and you will get this window. You can play around with your graphs like title, font, this and that, and so on. And then once you click, I will get the pop-up window. Okay, SimaPro, this demo version, this function is not available in the demo, so you need to have the license. But you can get the results out of it from the single from the inventory. Yes, from the inventory you can check the results in details. Okay, and if you really want to extract the results, you have to manually do that from the demo version, or you can take the screenshot to suggest to the designer. In the interpretations, so this is the interpretations. In interpretations, you can check. This is the interpretation here. You can see the results, but in short, I can say that this is all these details are written here, what the results are. But I can definitely say that the aluminum one has the more environmental burden compared to the plastic one, and this is because of the use of more resources and materials, as well as the energy in the usage phase or the other resources. So that's the reason it has more environmental burden. So you will be suggesting, of course, definitely the plastic one to the designer, and you will be explaining what the reason is. Okay. Okay, so this is all about the comparison and I have already discussed all these things. You can go through or play around with this one. And in method, you can discuss, you can check the method here. Like we have done the analysis using receipt method. So there are a bunch of methods here, like European method, global method. We used global receipt endpoint method, this one, I think, yeah. And if we click this one, you will be able to see what this method is, what the references are, and all these details are given here. North American method, and depending on your locations and from where you are analyzing this life cycle modeling, you can choose your method. But usually we use global method, but those who are from Europe, you can use this method as well, you know. Okay. And then calculation steps, there is nothing more to discuss here. Interpretation, I have already discussed this one. And documents link, these are the very important resources. This is EcoInvent database. You can go through this and understand more what this database means, from where they have got the data, and so on. All right, so this is all about the second part of the SimaPro modeling. And in the next phases, or in the next tutorial, I will be discussing more about how can we do the fresh analysis using some case study. For example, 1 kilogram of hydrogen production using PB system, what would be the environmental burden, what would be the disposal scenario, and so on. So I will do a fresh analysis using this software, and hope you have understood this one. And I would like to request you to subscribe my channel and hit like, so that you can get the next tutorial when it is uploaded. Thank you very much for watching.